So in yesterday's class, we discussed about the cryptography, the basics of it, and the techniques which we use for cryptography, right? And the techniques which we discussed were symmetric cryptography and asymmetric cryptography. In symmetric cryptography, we use the same key for encryption and decryption, or we can say at the sending end and receiving end. And in asymmetric cryptography, we use different keys for encryption the message, and we use different key for decrypting the message. Right, then we started discussing about symmetric key cryptography in detail, in which I talked about substitution method and transposition method. In substitution, what do? We substitute one character with another character, okay, and that change is always one to one. So you will be replacing one character. It doesn't matter how many times it appears in the text. So you will be replacing that character with the single character only. Okay, so you cannot use many characters for the single character for encrypting the message. The second was transposition. In transposition, what do? We only change the position of the letters. Okay, we do not change the value of the letters. We only change the position. We will discuss this transposition kind of this kind of cryptography in later classes, but now right now we are focusing on the substitution cryptography, okay, or we can say substitution category of encrypting the message. So in substitution cryptography, I told you about monoalphabetic ciphers and polyalphabetic ciphers. So we discussed some examples also for monoalphabetic. Monoalphabetic says that you are substituting the characters, and we are getting the encrypted message by substituting the characters, and those characters, you will replace one character by another character. So this relationship, or when you create the cipher text with the help of plain text, then the relationship between the symbols which we will be using in plain text and in cipher text will be one to one. So we discussed one example also for this. As I told you, in this particular example, what is happening over here, you can see that H is being replaced by K, E is being replaced by H, and here you see that there are two L's, okay, and both of them are being replaced by O. So we can say that this kind of encryption is monoalphabetic because the mapping is one to one, right? And this kind of encryption, we can say that this is not monoalphabetic, because here you can see both of these L's are having different value in encrypted message, right? So this is not monoalphabetic. Now under this monoalphabetic technique of cryptography, we have various other techniques which we will be discussing in today's class. So the very first one is called additive cipher. Okay, we have additive cipher, we have multiplicative cipher, we have affine cipher, and we have a monoalphabetic substitution. So one by one we will be discussing all these cipher techniques. So additive cipher, what do we do in this? This is also called shift cipher and Caesar cipher. Okay, but mainly we do not generally use this term shift cipher. We mainly use this additive cipher or Caesar cipher term for referring to this kind of cipher technique, right? So here what do we have is, we will be dealing with these values, okay, and the plain text and its corresponding cipher text will be from this set only. Okay, because why are we taking this set? Because there are 26 alphabets, right? And we are replacing one character by another character. Okay, so that is why we are using these 26 values over here. So say for example, if I have plain text and these are the entries for plain text, this small a b c d up to z, and I have this cipher text, the corresponding cipher text, which is capital A to Z, and these are the corresponding values for plain text and cipher text. So I can say that the value for small a and capital A, it is 00, or the value for say small q and capital Q is 16. So we will be using this value and their corresponding plain text and cipher text value for encrypting the message. Okay, we'll be using these values, and how do we do that? We will talk about it now. So this is additive cipher, and we use this kind of cipher in this way. So here is Alice, who is sender, who is having the plain text, and this is Bob, who is the receiver. So encryption will be performed at Alice end and decryption will be performed at Bob's end. Right. Now what we will do with this encryption, we are getting what? We are getting the cipher text, right? And this cipher text we get with this expression. So what we are doing is we are simply adding to plain text the value of key, which will be same for Alice and Bob, because this kind of ciphering technique, it comes under symmetric key cryptography. So they'll be using the same key. Okay, so this expression we will be using for creating the cipher text from the given plain text with the help of key value. Right, this mode 26 we are using because we cannot go beyond beyond these 26 characters which we were discussing over here. Okay, so that is why we are taking mode of this addition, mode 26 of this addition. Right, how do we calculate it and how do we use it? We'll discuss it in the next slide with example. But before that, you need to understand the process of this whole ciphering technique. Okay, so this is the this is the part which tells you that how do you encrypt the message using plain text and the value of key. Now at the receiving end, the same message will be decrypted. Okay, so here the value which we have added will be subtracted to get the original message. Okay, so this value of key we will subtract from the cipher text, and in result we will get the plain text. So here also we'll be using the value of key, which is same for Alice and Bob both. So if I make you understand with a simple example, say if I have a number, say 25, okay, and I need to send this number from this end, from the sending end to receiving end, and I cannot send it directly. Fine. So what I'm doing is I am adding a value, a key value to this number, so that this number directly is not accessible directly. Okay, so say for example the value of key is 5 and I add 25 I add the value 5 to 25. So as a result, what do I get? I get 30, right? But at the receiving end, if I need to find the original message which was encrypted, so what I will do, I will simply subtract that value which I have added to it while encrypting it. So I will simply subtract this value 5 from it, and as a result, what do I get? I get the original message, right? So this is the concept of additive cipher. You add some value over here to get the cipher text, and you subtract that value which you have added at the sending end to get the original message after decryption, right? So this is how this additive cipher works. So it is also telling you that when the cipher is additive, the plain text, the cipher text and the key are integers in Z26. Okay, so this will be the set. So we here in additive cipher we are using this single set. In multiplicative cipher we'll be using one more set. Why is it so? I'll tell you the reason while discussing multiplicative inverse. Okay, so this is how do we encrypt and decrypt the message using additive cipher. Now we'll discuss one example for this. So here, this is the plain text which says hello, and the value of key which is given as 15. So we will use the values which we have seen in this table. So I told you we will be using this table. So the values will be used from this table, and the value of key is given over here, and the value of plain text is also given over here. So what we will do, we will be using this expression which is a mess right now. uh, okay, so this expression we will be using to calculate or to find out the encrypted message. So we will see, or we will check, or will find out the values of these given characters in the plain text from the initial table, this table, right? We'll find the values. So here you can see that the value for H is 7, value for E is 4, value for L is 11, and the value for O is 14. Fine. So we will be using these values to encrypt the message. So here you can see the same values, right? So for encrypting this message, what we will do? We will add the value of plain text and the key. Okay, so this was the expression P plus K mod 26. So the value of P over here is, for H it is 7. The value of key will remain same for all the alphabets. It is 15, and we will calculate its mod 26. So as a result, we get here this will become 22. 22 mod 26 gives you 22, right? So for cipher text, we will get this value 22. Now what we will do, we will check for its corresponding alphabet, okay, from the same table, from the initial table. So we will check for the corresponding alphabet for this value. So here you can see 22 is having value as W, right? In the cipher text we have to check, not in the plain text. So in cipher text it is having value as capital W, right? So here we will use this capital W instead of what? Instead of H. So just like this, we will be calculating the encrypted form of each and every alphabet, and we will be replacing the whole message, which is hello, with this message, which is WTAAD. So here also you can see this L is having the same character, right? So that is that is because we are using monoalphabetic method, right? So this will be the encryption thing. Okay, so this whole part will give you it will give you what? It will give you the encrypted message from Alice end. Now when Bob receives it, it will try to decipher it. It will try to decrypt the message which it has received. So we will be applying the same algorithm, but this time we will be subtracting the value of key. Okay, because on the sending end we have added the value of key. So for decrypting the message, we will have to subtract the value of key from the values of the characters. Which characters? These characters, which is the encrypted message. So how this process works? This process works like this. So we will again find out their value, okay, which is the value of the characters which are there in the encrypted message. We will then subtract the value of key out of it and will find mode 26. So as a result, what do we get? We get this value, because 22 minus 15 mode 26 will give you yes, 7 mode 26, and the result will be 7. So again we will check the corresponding value of 07 in plain text, so which will be H. So just like this, we will calculate the decrypted value for each and every letter which is in the encrypted message. And as a result, we get, you can see over here, we get the original message, which was hello. So this is how this additive cipher works. We add the value of key at the encrypting end, and we subtract the same key value at the decrypting end, so that we can get the original message. Okay, so next is this. I already told you that this additive cipher is also called shift cipher and Caesar cipher. Now Julius Caesar was a person who used this additive cipher to communicate with his officers, and he used the key value of 3 to send the messages privately, right? So we also call it shift cipher and Caesar cipher. So don't get confused if you see these terms for additive cipher, right? Next kind of cipher is multiplicative cipher. So just as we add the values in additive cipher, what do we do in multiplicative cipher? We will multiply the value of key to get the cipher text, right? So here you can see, instead of adding, we are multiplying the value of plain text and the key, right? And we are then finding out the mode 26. So here also we are using the same key, because this is symmetric key cryptography. At the receiving end, what we are doing is we are dividing the value by k. Here we are multiplying the value. So at the receiving end, to decrypt the message, to get the original message, we will divide the value, right? Okay, so the same thing goes over here also. If you take that 25 example and the key is 5, okay, then what do you get over here while encrypting it? You get 125, okay? And at the receiving end, what will you do? You will divide this value with the value of key. So when you divide 125 by 5, you get 25, which is the original message, right? So this is how this multiplicative cipher works. But here, as we when we discussed additive inverse and multiplicative inverse, I told you that each and every number in the given set has the additive inverse. But in case of multiplicative inverse, each number in the set does not have its multiplicative inverse. So we need to choose the value of key such that the number which we have chosen for key, it must have a multiplicative inverse, which can be used by Bob while decrypting the message, right? So we will be using two sets for this kind of cipher, this multiplicative cipher. One will be Z26 and another will be Z26 star. So this set will be this set will be having only the numbers for which the multiplicative inverse is available in set Z26, right? So I will tell you that, which numbers do have the multiplicative inverse in this particular set Z26, and we will be using the value of key from that set only, okay, because we need to have some multiplicative inverse of the given number, which we will be using at the receiving end. Okay, so the process will be same for encrypting and decrypting the message as additive cipher. The difference will be there we were adding the values, here we will be multiplying the values, right? So here you can see that this Z26 star, it has only 12 members. It does not have 26 members, just as in we have in Z26. So it has these numbers only. And why these numbers? Because in the set Z26, these numbers have their multiplicative inverses. Okay, so that is why we have only 12 members in this set. Okay, so now we will use this multiplicative cipher or this method to encrypt the message hello with the key 7. Now you can see this 7, it is a part of Z26 star. Okay, so here it is. So you can use any of the key from this set. So here we are using key 7. So the ciphertext for this particular message will be this one. So we will see its calculation. How do we get it? Here it is. So again, the process will be same. We will get the values of the plain text. We will apply the encryption technique, which says P into K. So here P, the value of P which is plain text. So here for this step, the value of plain text is 7. So this is the value of H, this is the value of key, and we find its mode. So as a result you get 23. So we will check for the ciphertext which is there in the initial table, the value corresponding to 23, and that value is X. So we can check it also from that table, which is this one. Okay, so here you can see this 23 is having entry as X in ciphertext, right? So we'll be using this alphabet. Okay, yes, so next is E. The value of E is 4. We will again apply the same process and we get this value 2 over here, and its corresponding ciphertext value is capital C. So this is how we will calculate the ciphertext or the encrypted message using multiplicative cipher. Now we have encrypted the message. Now we will decrypt the message. Now how we will do that? Okay, this is not shown over here. So what we will do, we will simply find out the inverse of this 7 for this particular set, this set Z26, right? And we will be dividing this value, we will be dividing that value which will be the multiplicative inverse of 7 for Z26, right? And we will be getting the same value as 7, so that you can try by yourself, and if you face any difficulty then we'll talk about it in the next class, right? Okay, next kind of cipher we have is affine cipher. So affine cipher is a combination of additive and multiplicative cipher. So here we will first of all apply this multiplicative cipher, and then we will get the ciphertext using the additive cipher over this result. Okay, so this is the intermediate result this T will be the intermediate result. Okay, and this result you will get through multiplicative cipher, and then on this intermediate result you will apply additive cipher, which is this one. Okay, so here you can see we are using the expression of multiplicative cipher. We are multiplying the value of P and the given key, and here we are using the value which we have received or which we have got over here, and we are adding the value of key. Here we are multiplying, here we are adding. So that is why we say that this is multiplicative cipher and this is additive cipher, right? So the cipher text or the encrypted message you get after this step, right? So this is how we perform this encryption at the sending end. And then okay, one more thing, here we will be using two keys, right? Key this K1 and K2. This K1, this is being used by multiplicative cipher. So this key has to be from Z26 star, right? Because this is multiplicative cipher. Okay, and this key has to have a multiplicative inverse. So that is why we will use this key from Z26 star. This K2 key, it can be from the set Z26. Okay, because this is the additive cipher, and each and every number in the given set has its additive inverse. So we can use the whole set for this step, right? So at the decrypting end, what we will do, the operation which we have performed lately, okay, we will perform that operation first of all at the decrypting end. So here first we have applied multiplicative inverse, and then we have applied additive inverse. So at the decrypting end, what we will do, we will apply the additive cipher first, and then we will apply to the result, to this intermediate result, we will apply the multiplicative cipher. Fine. So this process is these steps which we have followed for encrypting the message, they will get reversed over here, and the keys value will remain same. K1 will remain same as the key value which you have used while encrypting the message, and K2 will be the same key which you have used over here, right? So this expression, these both of these expression, they can be written combinedly also, and this is how we write it. So what we are doing is we are multiplying them first, and then we are adding the value of K2 to the result. So here also you can see we are just adding K2 to this temporary result, which is the intermediate result T, and then we are finding out their mode. And at the decrypting end, what we are doing, we are subtracting the value first, and then we are using the multiplicative inverse, or we are dividing this value with the multiplicative inverse. Fine. So this is how we implement a fine cipher for encrypting any given message. So here also it is telling you that this is the multiplicative inverse of K1, and this is the additive inverse of K2, right? Okay. So here is the example. You can see that the pair is given and the plain text is given. So this is the pair. This is K1 and this is K2. K1 you will use for multiplicative cipher, and this you will use for additive cipher. Right? For encrypting it, what we will do, we will be using the keys and the value of plain text. Right? So this expression was like this. I'll show you. P into K1 plus K2. So here this is the value of be 7. So 7 is here into K1, which is 7, and plus K2, which is 2. So as a result, we get 25 over here. So we will check the corresponding value in the cipher text in the very first table. So we get this Z over here. So just like this, we will calculate the value for each and every variable, right? And you can see again the value of L is same, right? For both of these L's, the value of cipher text is same. That is because of this monoalphabetic cryptography or monoalphabetic technique, right? Okay, so this is the decryption part of the same message using affine cipher. So here you will be having the encrypted message. Here what will you do first? You will be applying the additive cipher using the using the value of key, and then you will be applying the value of this multiplicative inverse, or you will simply divide this whole value with the this 1 by 7, right? So as a result, we will get the 7 over here and its corresponding plain text we will get as the result. So here also you can see you are getting the original message, right? Okay, so this is all about affine cipher. Next kind of technique under monoalphabetic substitution technique is its name is same, actually, monoalphabetic substitution cipher. Now what happens with additive, multiplicative and affine cipher, that the number of keys which are available to use, they are very limited. Okay, we have at most 26 keys, right? So if the brute force attack happens, which exhaustively searches for every possible combination to find out the encrypted message. So this brute force attack, if it happens, then your message is it becomes vulnerable to the attacks, because finding out the right value of key becomes easy for intruder. So this kind of cipher, this monoalphabetic substitution cipher, it offers you a solution which is better than additive, multiplicative and affine cipher. It says that you create this table, okay, which is having the plain text value and its corresponding cipher text value. It can be any value, okay. So here you can see these alphabets are written randomly. So this value of cipher text can be anything from capital A to Z, but the sender and the receiver, they must agree on these values. They must know priorly that these are the values which will be used for encrypting and decrypting the message. So here we are not using any key, just to be safe from brute force attack, because the when the number of keys you have, when the numbers of key which are available is less, then you become more prone to the attacks. So here what we will do, will be deciding these values first of all, and then sender and receiver, they both will agree on it. They both will have its copy, and then the message will be sent after encryption, and at the receiving end, the receiver will also use the same table for decrypting the message. Okay, so as an example, if we see that if this is the message which is to be encrypted, then the corresponding cipher text we will get is this one. So here you can for verifying it, if we check for easy, we will check for its corresponding cipher text in the same table which the sender and receiver has agreed upon. So EASY, we will look for it. E, which is R, N, then V, and then S. So R, N, V, S. We will have it over here. So here you can see these characters, right? This T, you can check whether it is there or not. So this T is corresponding ciphertext is I. So we are doing what? We are simply replacing the characters from from this table, which is the values for which is these are decided beforehand. Okay, and both the sender and the receiver, they both have information about this table, so that they can use it for encrypting and decrypting the message. Right, so this is the last last technique for monoalphabetic techniques. Okay, so now see, this is the flow in which we are covering the topics. So maybe you are getting confused that we are just discussing the topics one after another, and this whole diagram will tell you that how we are following the hierarchy, right? So initially we discussed about cryptography, then symmetric key cryptography and asymmetric key cryptography. Then in symmetric, we discussed about substitution cipher and transposition cipher. This transposition cipher we'll talk about later. Okay, right now we are focusing on substitution cipher. So in substitution cipher also we have monoalphabetic and polyalphabetic. In monoalphabetic, which we have discussed today, we have covered this additive or a Caesar cipher, multiplicative cipher, fine cipher, and monoalphabetic substitution. So for the next class, we have this topic, this polyalphabetic substitution cipher. Okay, so this is the hierarchy which we are following. So after completing it, we'll be moving to transposition ciphers and then to asymmetric ciphers. We will also cover some famous algorithms which are symmetric key algorithms in this, and then we will move to asymmetric key cryptography. Okay, so that's all for now.